Hey guys, a quality control inspector needed to inspect the amount of milk that was being poured into 64-ounce containers. So he randomly chooses 40 containers. And that's actually wonderful because what I wrote here was n equals 40. And when n is greater than or equal to 30, we can use the central limit theorem to show that the distribution is approximately normal. So that's key in this problem. In the sample of 40, let's get back to the highlighters. In the sample of 40, he found that the average amount of milk was 61 ounces. So I put that right there with a standard deviation of 1.4. The reason why this is actually really important is because this is an S. The reason why it's an S and not a sigma is because in the sample of 40, this is what came from it. It came from the sample, so this is the sample standard deviation. It didn't say it is known that the standard deviation is 1.4. It says from the sample, it's 1.4. That requires us to use a T. It doesn't matter how large n is. If you have S, you must use a T. The degrees of freedom for a T is n minus 1. So its degrees of freedom is 39 in this case since n is 40. So we know that a confidence interval, it's a 95% confidence interval. We know that a confidence interval requires 3 steps. Your first step is your condition. All conditions, there's going to be 2 of them. So the stem states that the containers were chosen randomly, okay? So that says here, he randomly chooses 40 containers. Then, as I said earlier, n is equal to 40, which is greater than or equal to 30. So by the central limit theorem, we can assume the distribution is approximately normal. So that's step 1. Step 2 is going to be our formula. We remember one of the most important things here is that it's a 1 sample. You have to decide whether it's 1 sample or 2 sample. Every single example, you must decide if it's 1 sample or 2 sample. So we know our formula is going to be statistic plus or minus critical value times the standard deviation of the statistic. This is called, I have in red, the standard deviation of the sampling distribution or the standard deviation of the statistics. They're both the same. This is the critical value. That's our T. So when you take the T and you multiply it by this, you get the margin of error, okay? So the margin of error is this part here. And remember, margin of error, usually the questions require like for us to find the sample size or whatever. Okay, so my formula, it's a 1 sample, okay? And it's going to give you an option between sample mean and sample statistic. We're going to choose sample mean or sample proportion. So we're going to choose sample mean, then critical value, 95% confident with 39 degrees of freedom. That's like the proper notation, S times the square root of n. Remember, all you have to do is fill this out. Now, we're not going to be able to find this T on our chart, okay? So we're going to need to use our calculator. So let me remind you how to find the T. In this case, you're going to go to your calculator, you're going to hit second, and then you're going to go to vars. Once you get there, you're going to go to inverse T. You're going to have to put an area in the degrees of freedom. We know that the degrees of freedom is n minus 1, so it's 39. The reason why I have 0.025 there is because this is a 95% confidence interval. There's 0.025 left on each side. So you just put 0.025 and then you're going to press paste, which is sort of blacked out here. Once you press paste, you get this number right here. Notice how the number is negative. It's just saying that, hey, this is the lower limit. Okay, so this is 0.023, let's say. Okay, if you wanted this one, they're symmetrical, so that's going to be positive 2.023. If you wanted your calculator to give you that, then in here, instead of that, you're going to be putting 95 plus this, so you would actually be putting 0.975 here, and that would give you the upper limit. But it makes no difference because negative 2.023 2.023, remember, it's going to be a plus or a minus, okay? So it's 2.023. Once you set it up, you go to your calculator and you press stat by itself. You go over to test. Remind yourself that the first 6 are always for hypothesis test. After that comes the intervals. It's going to be a t interval. You're going to put 61, 1.4, 40 is your n, okay? And then 0.95. You press enter and you get this number here. Okay, so that's your third, that's still in your second step. So you should go back and 60.552, you should probably put that here, okay, on this page, the interval. So once you put this down, now we need our interpretation, which is really, really important. So you're gonna go here. Your interpretation is gonna be based on these samples. We are 95% confident that the true mean amount of milk in the 64 ounces 64 ounce contained is between 60.55 and 61.45 ounces. And that's how you do a confidence interval. So just a friendly reminder is going to be 3 steps. You're going to need to decide if it's 1 or 2 sample, and then just use your formula sheet for the 3 steps. Remember that n has to be bigger than 30, or you need a picture, okay, stem plot, dot plot, box plot, something to show that there's no unusual features. And finally, they can tell you, but you cannot use n times p because there's no p here anyway, and that's for proportion. So this is for average, and the central limit theorem only applies for averages, okay? So that's how we do a confidence interval. I hope this was helpful.